Welcome back. We will look at some additional features of a start-stop hybrid vehicle. We had introduced the start-stop hybrid vehicle in the previous lecture. The focus here would be what are the possibilities for rechargeable energy storage system that goes into this slot in this process diagram. So we had mentioned batteries are a possibility, but in addition, there are other possibilities, which is what we will address in this lecture. So we'll focus on three particular phases of this system. There is this phase wherein engine is off. Still, you want to be providing power to, let's say, the accessories. That can be an air conditioning unit or a lighting of a car or a radio, let's say. Okay, so you are not operating the engine, so this has to be powered. Therefore, you are using this, let's say, via powering this via a battery. That's a possibility. So engine is off. Then engine restart, you're restarting the engine. So there is a burst of power that is needed, and that is indicated by this link, right? So you typically, in traditional cars, you had starting, lighting, ignition batteries, which operate in a narrow SOC window that goes towards starting the battery. Okay, so that we have already covered. So that is another phase of the car. Then you have a recharge of this particular system. So there are three different phases. So this start-stop hybrid architecture is very similar uh, to a conventional car, because even in a conventional car, you had SLI batteries. The SLI starting, lighting, ignition batteries only contributed towards starting, lighting, and ignition. In addition to that, we have additional loads, let's say running the air conditioner and so on. So there's only marginal difference between a start-stop hybrid architecture and the traditional car. The sizing can be different. So let's move on. So what is presented here are the different phases. So if along the y-axis, we are talking about, let's say y-axis is above zero. That means energy is taken out of this RESS. Remember, RESS refers to rechargeable energy storage system. So above this line, energy and power is taken out of RESS. But what is to be noted is when the engine is restarting, there is a narrow time window wherein a burst of power is required. So this can be of the order of minutes, but this is of the order of seconds. Okay, so you want to restart the engine very quickly. So this is a narrow time window, but the power requirement is quite high. Then again, there is this phase T3, for example. T3, in this phase is much larger than this time window as well as this time window. So in this phase lies below this line. The RESS gets recharged. So this phase refers to engine off. This is this phase, and this is this phase. So because you require a burst of power or a narrow time window, in addition to a battery, there is another electrochemical energy conversion device, or energy storage device that may do the job, and that is the capacitor. We have already presented the features of capacitors. But what is to be noted is that as you pull out charge from a capacitor, the voltage of a capacitor comes down. So there is a linear dependence between the voltage of the capacitor and the charge that is stored, charge and energy that is stored in a capacitor. We had mentioned that a battery cannot be used below a particular voltage, right? There is a particular cutoff voltage below which the battery becomes useless. Likewise, if the capacitor's voltage goes below a particular cutoff, the capacitor is also not useful. So not all the charge can be obtained from a capacitor, because when as you discharge the capacitor, the voltage gradually comes down, and you do not want to be operating the capacitor below a particular voltage. So typically you operate the capacitor to, let's say, 0.5, half of the maximum voltage. So you do not want to be operating below this voltage. So the usable energy is equal to QV. So the usable energy from a capacitor is in this region. So the usable energy is in this region. So the energy of a capacitor is uh, the energy stored in a capacitor depends upon the maximum voltage of the capacitor. Half CV max squared is the total energy stored, out of which not all the energy can be drained out of a capacitor. Only a part of energy that can be drained out, that is given by this formula, just by geometric construction. So this is the usable energy from a capacitor. Because the molecular mechanisms that are involved in a capacitor, while it stores energy, are different from that of a battery. In a battery, typically there can be ion intercalation, or in the case of conversion batteries, there can be new bond formation. Uh, as opposed to that, the electrochemical capacitors store energy because of the electrochemical double layer. That has an advantage, but it also has a disadvantage. Typically, these interactions can be broken more easily. Therefore, the self-discharge of a capacitor is greater than the self-discharge of a battery. So this is a disadvantage, but the number of cycles of a capacitor is also greater. In addition, it can discharge very rapidly as opposed to a battery. So all these things you have to think in terms of trade-off. When you gain some, you are also losing something else. Understanding this trade-off is what is engineering. So we have addressed many of these issues in previous lectures. So in the next lecture, we will address the battery features if you have a full hybrid vehicle. We'll also define what we mean by a full hybrid vehicle in the next lecture. Thank you.